Some remarks about how to write portable C code. First of all undefined behaviors should be avoided. And implementation defined or unspecified behavior should only be done so that it doesn't affect the output of the program. And if you want your program to work on different operating systems, then try to use the standard C library functions as much as possible. For instance, in Mac OS and Linux, you can remove a file using the system call unlink. But there is a library function which is portable to other systems called remove. So that is preferred. But on the other hand, if you already use lots of Unix specific system calls, then it may not be so very important. Okay, and if you use C, if you have written a program which produces C code, then there is a risk of exceeding some limit, such as the number of parameters, for instance. So that should be checked. And if you want to go learn more about this, there is an appendix in the C standard that you can check. The C standard is expensive, but you can find the last draft using a Google search, and usually it's available from Wikipedia as well. I mean a link to it. And the last draft and the official standard, they are essentially identical. Okay, unspecified behavior. Examples: if two identical string literals are they put in the same memory, or are there different copies of hello world, for instance? Other things, the order of evaluation of operands in binary operations, the order of evaluation of function arguments, where the arrow, we will come to that when we talk about the C library, but it's a place where error conditions are stored, and it behaves as if it is an integer, an int. But to handle the situation where we have a multi-threaded program, this arrow should sometimes be local to a thread and sometimes be for the entire program. So there is there are some fixes which make it appear to be an int, but sometimes it's a macro. And typically what this macro does is that it calls a function that returns a pointer and then dereferences this pointer. Okay, if we have several hash and hash, in which order are they evaluated? That's not the most important problem that the C programmers face, but it still can make okay, so if you want to use both of these, then make sure the output is not dependent on their evaluation order. Okay, there is a library function called bsearch or binary search, and then if there are identical elements, which one is used? Returned. And the same for qsort, which usually is quicksort, but doesn't have to be it. At least it's not guaranteed to be a stable sort. What happens when we get an overflow, when we convert from a huge floating point number to an integer? or converting a non-integer floating point value to an integer, and will that need to raise an exception called inexact. I mean, if we round it, then it can or I mean, either it does or it does not raise an exception called inexact. And which one of these are called first? Undefined behavior. Well, they are different, but one is to return a pointer to a local variable and then use that pointer. That's a bad idea. But in fact, it's used for, you remember, there is a function called alloc A. And alloc A needs to know in which direction the stack increases, to lower or to higher addresses. And a way to figure that out is to do exactly this. But it's undefined behavior, but sometimes you may know that it will work. Okay, here is a funny thing, namely how to crash a program sometimes. If we have this car pointer and we let it point to a string literal, then what happens? Well, this string literal may be stored, I mean the hello world text may be stored in read-only memory, and then if we modify this, the program crashes. But it's not certain that it's stored in read-only memory. So what can have happened is that we could modify it, but the hello world was occurred in several places in the program, and the compiler has figured this out and share the memory for these strings. And then we could change all of the strings, for instance. So this is a bad idea. Another thing, we shouldn't modify a variable multiple times between two sequence points. And recall, a sequence point, the most common sequence point is a semicolon. Okay, what happens with divide or remainder if the second operand is 0? Examples of implementation defined behavior. The number of bits in a car. You may assume a byte is always 8 bits. That has been the case since IBM 360. But in C, a byte is at least 8 bits. And a byte is always exactly the number of bits as a car. There is no type byte, but still the concept is used. Okay, and it's implementation defined, where the car actually is a signed car or an unsigned car. Another implementation defined behavior is how integers are represented, but you will be quite proud if you can find a computer where where signed integers are not to complement. The best place to search for them is in an old computer museum, so it's not a big issue. But say you have, now we come to something else. If you have made a library and for instance you want to put your int opt with both integer linear programming solver and the simplex algorithm in a library and in a header file that you want to be able to use with this less than and greater than. Then it's implementation defined how to write that on the command line to the compiler. But on Linux and Mac OS, and other Unix systems, you should write like this: -i and then the directory name, and then the compiler will search that directory for files with these kinds of brackets. If you use a normal string, then it will search in the current directory. Okay, and endianness, in which order data which is multiple bytes is stored, either starting with the least significant byte or with the most significant byte. And that can be checked during runtime, of course.